Guys, we've been insulating our metal buildings wrong, and it has nothing to do with our value and everything to do with air movement. And it may be hard to believe, but whether you choose spray foam or foam board or even fiberglass insulation, if you don't take these extra steps, it's gonna cost you a lot more time, energy, and money. Welcome back to Dale Does It All. So I've spent a lot of time deciding exactly how I want to insulate my 30 by 40 metal building. And while I was considering my options, there were of course the spray foam loyalists, which my dad is a recent convert to, who swear it's the best, and others swear by the simplicity and DIY nature of foam board, and many settle for the economic tried and true of fiberglass. And while neither completely eliminates the thermal bridging that reduce the ability of this giant metal structure to act as a radiator, but what if we're all focusing on the wrong thing? Because the more I looked into it, the more I realized that insulation wasn't even the biggest player in the problem. And in fact, the real player was air. And although that sounds pretty obvious, what's not so obvious is its impact. Let me show you what I mean. Like most buildings, you're gonna have small cracks and gaps in the metal members and the structure, the panels, and it's gonna be in houses, buildings, garages, shops, they all have them. The subtle differences in geometries when they're all put together comes up with just slightly off corners or little places where small amounts of air can just move freely. What's different isn't whether they exist. What's different is what we do about them. Many of us notice these types of small gaps, but we tend to focus on the bulk of the work, like the R value that we want to put into our walls, into our ceilings, and how much insulation we can really squeeze into a certain space or cavity. Yet in reality, when you view this building like a bucket and that precious, precious heat as water, then suddenly it all starts to make sense. Because no matter how well insulated that bucket is, if there's holes, then eventually you won't have anything left. Okay, you get the picture. But because a lot of these small holes and cracks and gaps often go unnoticed, there's not really an insulation that can fix these types of things. Or is there? But before we jump into that part of the video, you're probably thinking that these little cracks can't amount to that much. But that's where you would be wrong. Like, okay, yeah, you showed me that all the water is pouring out of the bucket, but that's not a realistic example. And in relation to the bucket, to the hole, to the flow of the fluid in the bucket, what would be a real world comparison? And the small gaps that I showed you earlier, what type of impact could they have on the efficiency and the ability to heat and cool this metal shop as it is today? Even though this gap looks small, it's basically an open pathway for air to move in and out freely, taking our heat and air conditioning with it. Now you might be wondering, how would you even start to estimate that type of thing? Well, engineers and HVAC technicians actually use a simple equation to calculate this. So let's make this interesting. Let's say it's a slight 5 mile/hour breeze outside, nothing crazy. And inside the shop with our heater running, we're about 30 degrees warmer than outside. In those conditions, a 1-inch gap like this can move nearly 8 cubic feet of air per minute. No way. That means every hour, this tiny gap is leaking hundreds of BTUs. And maybe that doesn't sound like much until you realize it's just one gap. Now add the seams around the doors, the seams around the windows, the overlaps, the place you don't notice above the doors, and suddenly you're losing thousands of BTUs every single hour. God. Over 24 hours, a gap like this can move more energy than a 737 engine produces in a minute at takeoff power. And yes, I'm qualified to make this statement because I literally build 737 engines. So now you're probably thinking, well, that's why everyone's such an advocate for spray foam. And honestly, that makes sense. Spray foam closes cracks, it fills gaps and voids, and stops a lot of that airflow. That's one of the many reasons that people say that spray foam is the answer. But it's not the only one. And if you could solve the air gap problem first, would spray foam still be the best choice? So I decided to compare the two, the cost and the energy from spray foam use and DIY foam board. And the results might actually shock you. Spray foam is kind of the gold standard for metal buildings. It seals air leaks, adds insulation, and bonds everything together in one step. It works, and it works well. But that performance comes at a cost. For a building this size, most quotes land somewhere between $6,000 and $8,000 installed. And that price makes sense. It's labor, materials, equipment, and experience all rolled into one job. So from a performance standpoint, spray foam is hard to beat. But the real question is, how much of that performance advantage actually translates into savings over time? Because if I can eliminate most of the air leakage myself, then spray foam's no longer solving my biggest problem. And that's where the comparison gets interesting. Closed cell spray foam typically gives you around R6 to R7 per inch. So in a metal building like mine, where you might spray 2 inches on the walls, you're looking at roughly R12 to R14 across the shell. And that's real performance, because spray foam doesn't just add R value, it seals the surface, locks out air movement, and sticks directly to the metal skin. That means fewer thermal bypasses, fewer drafts, and a pretty consistent insulation layer. So in terms of raw thermal performance, spray foam absolutely works. Now, when you compare that to foam board, the numbers on paper actually start to look pretty similar. Most rigid foam boards land somewhere between R4 and R6 per inch, depending on the type. So if I install 1-inch board in the cavity, I'm roughly already in R5 range. Add the existing insulation blanket behind the metal, and suddenly I'm not that far off from the total wall value of spray foam. That's why sealing is important, because once the gaps are sealed, the foam board isn't fighting moving air anymore. It's just doing what insulation is supposed to do, slowing the transfer of heat. And once I looked at it as a system instead of a material, the gap between the spray foam and my DIY approach started shrinking pretty fast. Because if the energy savings only amount to small gains over time, the math starts looking very different. I only plan to heat or cool this building on the weekends, roughly 10 hours a day, Saturday and Sunday. So about 20 hours of conditioning per week. Based on the R value difference between spray foam and my sealed foam board setup, a properly sized 24,000 BTU mini split would probably use around 1.5 to 2 kilowatt hours per hour with spray foam, and closer to 2 to 2.5 with my DIY option. So we're talking about roughly half a kilowatt hour per difference. That works out to about 500 extra kilowatt hours per year. At typical power rates, that's roughly $50 to $80 per year difference, and a return on investment of over 50 years. So when it comes down to who's right in all of this, it really just depends on how you use your building. Not the comment section, not the internet, but you. Well guys, I hope you enjoyed the video. Follow along and subscribe if you like this content, and I'll see you on the next one. Doe does it all. Catch you later.